The objective of this lesson is to find a line or lines of symmetry in two-dimensional figures. Two-dimensional shapes were learned in previous lessons. For review, they are shapes with only two dimensions, meaning they have width and height, but no thickness. The vocabulary that will be used in this lesson is symmetry, which is when one half of a shape is exactly like the other half. The line where the shape can be divided to show the exact sides is called the line of symmetry. If a shape has no lines of symmetry, it is considered asymmetrical. Some shapes are symmetrical and some shapes are not. For the shapes that are symmetrical, there is a possibility that there may be more than one line of symmetry. Let's look at an equilateral triangle. All sides and angles are congruent on an equilateral triangle. Let's see if we can fold this shape so that one half is exactly the same as the other half. Then let's draw a line where we folded it. This line is called the line of symmetry. Let's try folding it again and again. Every time we fold the triangle so that each half is exactly the same as the other half, we have found another line of symmetry. We can say that the equilateral triangle has 3 lines of symmetry. For another example, let's look at this right triangle. On this right triangle, the sides and angles are not all congruent. Can we find a line of symmetry on this shape? Let's fold it. Try folding it again in other directions to see if there are any lines of symmetry. We can see that this right triangle has 0 lines of symmetry, so we consider this right triangle asymmetrical. Let's look at a different right triangle. This triangle has 2 sides and 2 angles that are congruent. Do you see a line of symmetry on this triangle? If not, to make it easier, let's try rotating it. We can see that this right triangle does have a line of symmetry. For our last example, let's look at a rectangle. Is there a line of symmetry on a rectangle? If so, where is it? Let's try folding the rectangle in half on the shortest side. Is there more than one line of symmetry? Can the rectangle be folded diagonally to find the line of symmetry? No. Now let's try folding the rectangle on the longest side. We can see that a rectangle has 2 lines of symmetry. Our objective in this lesson was to find a line or lines of symmetry in two-dimensional figures. We met this objective by looking at two-dimensional shapes and determining if there is a line of symmetry, and if so, how many lines of symmetry does the shape have?
In this lesson, students will be able to estimate volume in liters. Previous to this lesson, students learned what a liter is and used it to measure the volume of different containers. Students need hands-on experience with measuring with liters so they are familiar with about how much a liter is. You might find it helpful to compare a liter to a quart, since many students are familiar with quart jars or milk cartons. Point out that a liter is just a little bit more than a quart. Students may also be able to connect with the size of 2-liter soda bottles. Help your child make as many connections of objects that they are already familiar with to help them remember the size of a liter. Let's start by looking at the following container. Estimate, how many liters do you think this can hold? Remember, an estimation is just a reasonable answer. It's not meant to be exact, just close. Comparing the container to my liter measuring device, I notice that it's taller, but it's also narrower. So I think that the water would come up a little higher in that container. So I think that that container will also hold just 1 liter of water. I'm going to draw a picture of the container to record my estimate. Here's my container, and I estimated that 1 liter would fill it to the top. Now for the fun part. Let's pour the water and check our estimate. It looks like there's just a little bit of water left in my liter measuring device, and this one is filled to the top. So my estimate was correct. That container holds about 1 liter. Let's look at a different container. How many liters do you think this can hold? Comparing the container to my liter measuring device, I estimate that it will come up a little more than halfway because I can see that the bottom of this container is just a little more narrow than my measuring device. so I would expect that the water would reach a little higher in the container than in my measuring device. I'm going to draw a picture of the container to record my estimations. Here's my container, and I estimated that 1 liter would go about here. Even though that is more than halfway up the container, I think my container could hold 1 more liter because the container gets wider at the top, so there's more room than in the bottom of the container. Now let's check our estimate. Looking back at my drawing, it looks like my estimate for 1 liter is fairly close, so I'm not going to change my estimate of where I think 2 liters would be. I still think it will hold that 2nd liter. I have just a little bit left in my measuring device, so my estimate was correct. This container holds about 2 liters. Our goal today was to be able to estimate volume in liters. We did this by comparing a liter container to our jug and reasoning about the size. Then we drew a picture of our container and recorded our estimate on the picture. Then we checked our estimate to determine if it was reasonable.
The objective of this lesson is to multiply a whole number by a decimal in the tenths using base 10 blocks. In a previous lesson, students learned how to multiply whole numbers by a decimal in the tenths using hundreds grids. This lesson uses an array mat and base 10 blocks as another method to solve whole numbers multiplied by a decimal in the tenths. In previous lessons, students have also learned how to solve whole number by whole number multiplication problems using arrays. Let's start with our first problem. Sydney is training for a marathon. She decided that for the next 4 days, she would run 2/10 of a mile farther than she usually runs. By the end of the 4 days, how much farther did she run than usual? Start by writing the multiplication problem. Sydney ran 4 days at an extra 2/10 each day. This would be written as 4 multiplied by 2/10, or 4 groups of 2/10. 4 is the number of groups or number of rows, and it will be written on the side of the array mat. 2/10 is the number in each group and will be written at the top of the array mat. Place 2/10 rods in the first row of the mat. This represents the 2/10 mile extra Sydney ran on the first day. There are 3 more days to represent. Place 2/10 in the second row, 2/10 in the third row, and 2/10 in the fourth row. There are a total of 8/10. Sydney ran an extra 8/10 of a mile. In our previous lesson, this same problem was completed using hundreds grids. Both methods produced a clear product of 8/10. Let's solve another problem using the base 10 blocks again. Noah's dad is building a doghouse for their newly adopted dog. He needs 2 boards that are 1 7/10 feet long. What is the total length of the 2 boards? The multiplication expression is 2 groups of 1 7/10. 2 is the number of groups and will be written along the side of the array mat. 1 7/10 is the number in each group and will be written along the top of the array mat. Leave room between the 1 whole and 7/10 to place the place value blocks. In the first row, place 1 whole or 1 flat along with the 7/10 or 7 rods. Now in the second row, place 1 flat and 7 rods. There are a total of 2 flats and 14 rods. Because there are more than 9/10, regroup 10 of the rods into 1 whole. Now there are 3 flats or 3 holes and 4 rods or 4/10. The length of the 2 boards total 3 4/10 feet. This same problem can be shown and solved by using the box line dot method as well. Instead of placing base 10 blocks out on the array mat, the blocks can be drawn. Start by writing 2 along the side of the array mat and 1 7/10 along the top. Draw 1 box or 1 hole and 7 lines or 7/10 in the first row. Draw another 1 box and 7 lines in the second row as well. There are a total of 2 holes and 14/10. Regroup 10 of the tenths into 1 box or 1 hole. There are a total of 3 holes and 4/10. The total length of the 2 boards is 3 4/10 feet. The objective of this lesson was to multiply a whole number by a decimal in the tenths using base 10 blocks, and we met this objective by using base 10 blocks as well as the box line dot method to solve decimal multiplication problems.